Hello everyone, I am Shaluka Wijesiri and I am presenting on behalf of my supervisor engineer M.D.J.P.Wickramasooriya from Irrigation Department, Sri Lanka. I am presenting my study titled Correlation and Nomograph among Index Properties, Compaction Parameters and Particle Size Distribution of Sri Lankan Sandy Soil. Uh, this introduction. The study mainly focuses on developing new correlations and developing a nomograph to estimate compaction parameters of sandy soil in Sri Lanka with the help of regression analysis. The main objectives of the study is to study the interdependency between compaction parameters and index properties of Sri Lankan sandy soil. The methodology of this research is given in this slide. Collecting of relevant test data was done after thorough literature review, and analyzing of the test data was done using the regression analysis to obtain correlations among the parameters, and the results were checked for general use through a verification testing sequence. And the data collection process, the research was based on sandy soil data obtained from the following places in Sri Lanka, from Kudaya, Burrow Pit investigation, and some other places. The test standards of the obtained data was done complying the required standards of ASTM test procedures. And the main tool used for the study was regression analysis. Linear regression analysis was done in following procedure. Firstly, the variables were defined and the outliers were detected, and the coefficient of correlation and the statistical significance was checked for each obtained equation. And the nomograph was developed to determine the optimum moisture content with the help of the parameter Fa and the plastic limit. And the parameter Fa is defined specifically for this study, and it is defined as the summation of the percentages of particles by weight passing 2 millimeters U and retained in 0.001 millimeters U. And the analysis is carried out as a comparison between three segment between index properties and compaction parameters in three segments. First one is the reference research paper reviewed estimation of soil compaction parameters based on the Atterberg limits from 2013. And the second one is the results of the analysis of the test data obtained from the irrigation department, and the third one is the results of tests performed for the verification. And this following three graphs demonstrate the comparison of correlation between optimum moisture content and liquid limit of the reference research paper, equations obtained through regression analysis, and the graph developed for the verification through the results of the laboratory testing. And this is the comparison between the optimum moisture content and plastic limit, and it can be seen that the gradients of these equations are noticeably similar. And this slide shows the comparison between optimum moisture content and plasticity index, and it can be seen that the gradients of the reference research paper and graph and the verification graph is noticeably close. And this is the comparison between maximum dry density and liquid limit graph, and it is noticeable that the intersection of the three graphs are almost equal. And this is the comparison between maximum dry density and plastic limit, and again the interceptions of three graphs are somewhat similar. And this is the comparison of three graphs between maximum dry density and plasticity index, and again the interceptions of three graphs are not really similar. And this slide shows the nomograph developed to determine the optimum moisture content. And the conclusions. It must be emphasized that use of these equations developed in the study should be limited to clay sands in Sri Lanka, and the ranges of index properties seem to be low in both analysis data and verification data. If the data samples were selected in wide range of index properties, and the results would be more accurate. And the number of test sessions performed to verify the obtained results were low due to the limited time scope of this project, and the verification should be done with more number of test results for more accuracy. And these are the proposed future developments for this study. And the more number of data can be used in this analysis to improve the accuracy of the nomograph. And the FA parameter limits were 70 to 100, and the plastic limit the limits of the plastic limit were 50 to 25. And with these limitations, the optimum moisture content range limits as well. The parameter FA and the plastic limits can be increased to improve optimum moisture content limits. And there are a number of complex nomograph types such as end to Z charts, proportional nomographs, concurrent scale nomograms, and compound nomographs to increase the accuracy of the output variable. And this nomograph is developed for sandy soil, and nomographs can be developed for various other soil types as well for accurate results of those soil types. And these are the references we have used for this study. And thank you very much for listening.